All right, everyone. Thanks for joining me today. I'm Frank Roberts from First Line Technology. We're going to go through the science of decontamination. This is a quick drop from First Line that dives into what decontamination really means, some of the science behind it, and why it matters so much, especially when we're talking about hazardous materials or mass casualty incidents. Quick heads up, this program is proprietary to First Line, so everything we're covering is meant as guidance. It's your responsibility to make sure it fits in with your agency's policies and your scope of practice. Also, your agency has to be properly trained and equipped to actually perform these tactics. Basically, take this seriously, but stay within your operational lane. So let's set that foundation. What is decontamination? According to NFPA 470, it's the physical or chemical process of reducing and preventing the spread of contamination from people or equipment at hazardous materials or WMD incidents. Basically, we're talking about stopping hazardous substances, whether that's chemical, biological, radiological, or even toxic industrials, from hitching a ride on people, gear, vehicles, or infrastructure, and then spreading elsewhere. Decon isn't just about the person who's contaminated right now. It's about preventing that person or equipment from being a secondary source that continues to contaminate other people and places. Think of it like this. You don't just wash the mud off your boots to keep your feet clean. You do it so you don't track mud all through your house. Decon is something we often make overly complex, overdo, and overthink. We never step back to ask ourselves, is this efficient? While the way we've been doing decon has been effective for as long as we can all remember, we never look at what is beneficial to the situation. That being said, there is a time and place for all things decon, but today let's talk about making it simple. One method of decon is simply removal. That means physically taking the contaminant off of a surface so it can't cause harm anymore. We have two main approaches here. Dry decontamination, which uses something like FiberTect, which is a special composite wipe with activated carbon and absorbent fibers. It works through absorption, pulling stuff into it, and adsorption, binding stuff onto the surface. This is huge if you don't have water or if you want to avoid runoff problems, because sometimes rinsing contamination off with water just moves that hazard somewhere else. The other approach is wet decontamination, where we use a surfactant-based liquid to break the bonds between the contaminant and the surface. Think about how dish soap breaks up grease on your plates. Same principle. It emulsifies oily or sticky agents, making them easier to rinse or wipe away. This is critical for things like nerve agents or opioids that are oily or have high skin permeability. The next method is to actually destroy the contaminant. This is where we shift from just wiping it away to chemically neutralizing it. This is called reactive decontamination, and one of the best examples is Dahlgren Decon. It's a three-part solution that, when mixed, generates peracetic acid. That's a really powerful oxidizer. It actually breaks the molecular bonds of a wide range of hazardous substances. This means we're not just moving or diluting the contaminant, we're changing it into something non-hazardous or at least way less harmful. That's especially important for chemical warfare agents like VX or mustard, certain biological threats like those viral emerging pathogens, and even emerging industrial or synthetic hazards that might not be fully understood yet. It's also fast. Some traditional neutralizers can take 30 to 60 minutes to do their job. Peracetic acid starts working almost immediately. Then we've got hybrid decon, which is hands down the best of both worlds. This process combines dry and wet decon in a specific sequence for maximum impact. Step 1, we use FiberTect to wipe down the person, gear, or surface. This pulls off the bulk of the contaminant quickly. The nice part is you've immediately reduced the hazard by removing large quantities of the threat without creating contaminated water or sludge. Step 2, we then go in with Dahlgren Decon to chemically destroy what's left on the surface. Why does this matter? Because it does three things. Reduces the time people are exposed to the hazard, which equates to a shorter exposure with less absorption into the body. Cuts down on the contamination spread because less is being moved around by water runoff or handling. And this also maximizes resource efficiency. Your chemical agent doesn't get wasted on large volumes of contamination since the FiberTect already picked up most of it. This is why hybrid decon is becoming the gold standard in many emergency response plans. All right, so we've covered the three main methods: physically removing contamination, destroying it with a chemical reaction, and then the hybrid approach that does both for maximum effect. This diagram here kind of lays it all out cleanly. At the top, you've got the science of decontamination, which splits into two fundamental strategies: removal and neutralization. Under removal, we've got two tools: dry decontamination with FiberTect, which uses that absorption and adsorption to lift contamination off the skin or equipment, and wet decontamination using the Part A surfactant from Dahlgren Decon, which acts like a heavy soap to break bonds between the contaminant and the surface. Then on the right, you got neutralization. That's where we use Dahlgren Decon parts B1 and B2 to form a strong oxidizer, basically chemically destroying the contaminant so it's no longer hazardous. All of this flows down to hybrid decon, which combines dry and wet methods in sequence. This gives you the speed and simplicity of dry decon, plus the thorough chemical neutralization or destruction of reactive decon. So this isn't just theory, it's a structured, layered approach that we apply in the field, especially under time-critical and high-risk scenarios. Where hybrid decon really proves itself is during mass casualty events. Imagine a large-scale chemical spill or a terrorist attack using a toxic industrial chemical. You could have hundreds or thousands of people exposed all at once. In these scenarios, you can't spend 15 to 20 minutes per person under a shower. You need something that's fast to keep up with the sheer volume of people, something that's scalable so you can adjust your approach whether it's 10 people or 2,000, and it's effective across diverse populations, meaning it works equally well on kids, elderly folks, or people with different skin types and clothing. The latest studies in DHS guidance actually show that dry decon is faster and more simple to deploy than wet decon by itself. And hybrid decon goes in even further, achieving better contaminant removal than either method alone. Plus, and this is key, the quicker you can remove the contamination from someone's skin, the less they absorb into their bloodstream, dramatically lowering injury severity. So this slide is about the most current evidence-based guidance we have on mass casualty decontamination. This comes from a major effort by the U.S. Department of Health and Human Services, specifically from ASPR and BARDA, who partnered with the UK's Home Office to create what's called the PRISM guidance, which stands for Primary Response Incident Scene Management. It's broken down into 3 volumes that collectively offer the first scientifically validated framework for managing large-scale chemical incidents. Volume 1 is the strategic guidance. It gives incident commanders and public health leaders the why, the rationale and policy level decisions that need to be made. Volume 2 is the tactical guidance aimed at operational leaders and planners. It dives into setting up decon corridors, managing throughput, coordinating with EMS, law enforcement, and hospitals. Volume 3 is all about the technical evidence behind the recommendations, the actual research studies that show why these approaches work. From this research, we've learned some huge takeaways that influence how we do decon today. Dry decon is significantly faster and easier to deploy than setting up a full wet decon process. It allows and requires fewer resources, no water supply, and no complex infrastructure, which is a game changer when time and logistics are tight. But importantly, hybrid decon, combining dry and wet, achieves the highest reduction in contamination. That means you get people cleaner, faster, and safer. And one of the biggest points is that time matters. The quicker we can remove contamination from someone's skin, the less it gets absorbed into their system, reducing systemic toxicity and injuries. So modern mass casualty guidance from HHS and BARDA doesn't just say, get them underwater as fast as you can. Instead, it advocates a layered approach, dry first, then wet or reactive as necessary, to maximize efficiency and protect the most people in the least amount of time. PRISM has given us the playbook for mass casualty chemical incidents, backed by peer-reviewed evidence, so we're not just guessing anymore. It's helping agencies across the U.S. and internationally shape their SOPs for chemical incidents so they're faster, more scalable, and ultimately save more lives. And that's the deep dive. If you're curious about setting up a training session or you want to see more of these methods demoed live, reach out to us. You've got my contact info there, plus Corey and Kevin. We love doing hands-on training because honestly, that's where it all clicks. So let us know what your agency needs and we'll figure out a way to tailor it to your operations. Take care.